you know, thousands of subscribers. Okay, guys, so I know most of you have been focused on your problem, but it's a good idea to go through the other problems that other people have been working on, because this kind of gives you a snapshot of what's on my brain for the quiz. However, these problems I've given you, they're too hard. Some of them are like, I can't have all of them on the quiz like they are, right? Like some of these problems are pretty hard. Yeah? Some of the problems are easy, so let's get to it though. So like number 1, I just said calculate, so there's just plain old long division. All right. Number 2 was transformation by graphing. I didn't bring my glasses, so I can't tell if you guys are right or wrong. It looks like it's possible. Yeah. So, but this here, I think it's unlikely I give this format on the quiz, just because it's just, I think there's a better way to test transformation by graphing than that. Problem 2 here, I'm going to run out of time if I'm not careful, was to factor completely in graph. So this one here, we had that kind of factoring on test 1, remember? Maybe even quiz 1. We've seen that before, this x to the 4th minus something. So then that factors into these guys, which then further factors down to this. This guy over here, I completed the square, and I got to this, which means I'm not done. That whenever you get a negative overall from this part of it, that means you can break it into 2 pieces like so. It's not prime, it factors. And yep. This is already posted in Canvas. Uh-huh. Yeah, you could have cheated and looked at the answer like back at 10. Wait a minute, we did 10 yet? Oh man. It's not good. Okay, well anyway, we posted at 10. I thought I posted in the middle of the class, but my bad. It's not a good sign. Wonder what I'll do in the next class. Okay, anyway, going on. So you make the sign chart, then you can graph, right? This one's fun because every one of the factors is linear. It's first order, right? So there's a crossing every time. So it goes plus, minus, plus, minus, plus, minus. I mean, it makes a very, you know, so many of the examples we've done, there's been some bounce. This one's got no bounce, you know? All right, moving on. Here, problem 3, you had x-intercepts of -3, 1, and 5, and you're told that it stays negative. That forces you to make each one of them a bounce, and then when you work out the algebra, the leading coefficient ends up being -1/15. So there's that one. That one was, I think, one of the harder problems. Problem 4, I asked you to find the oblique asymptote. So that's just fancy talk for do long division, and what you have before the remainder term is linear. Then y equals to that linear function will be what's called an oblique asymptote. You know, odds are fairly stacked against me asking you to actually graph such a thing, you know. Because why? Because we really haven't done many examples. It's a little bit tricky. So it's unlikely I'd ask one of these on the quiz or test. But it's something I'd like you to be able to identify if you saw it. All right. But anyway, so this is an oblique asymptote. Part B, I think I said completely factor this guy. So this one's interesting. The first thing's prime. This one breaks up into a product of squares, which then gives us this sign chart and that graph. We move along here. Problem 5, I like the transformations of graphing part. So you start out with the volcano, shift it 2 to the left, shift it 3 up, there you go. So I think they got the better deal, right? Compared to like problem number, what was it? 1? What's the one with the square root? That one's more troublesome. Now part B, I forgot to solve part B, so it ended up on the margin here. So here's part B of number 5. What's going on here is whenever you've got the same factor above and below, it's a hole in the graph, right? So we've got a hole in the graph at -2. Also, if you look at this, you've got quadratic over quadratic. The leading coefficient on top and the bottom is 1. So we've got a horizontal asymptote of 1. The reduced function is when you cancel out the x minus 2's, or the x plus 2's rather. I should say there's a hole in the graph at 2. And so when I plug in 2 into this, I get 2 plus 3 over 2 plus 2, which is 5 over 4. So 2 comma 5/4 is the hole in the graph, and it looks kind of sort of something like this down here. Where was 5? Yes, it's getting there. Signs of life. So the quiz is not until when? Thursday. There's still time. So what's that? So yeah, this is a little off, but there are some good things here. Like the vertical asymptote, I think, is in the right place, right? There is indeed a vertical asymptote at -2. They got that right. Yep. So that's part of it. This would get partial credit. Problem 7 is important. Everyone should carefully sort through problem 7 when you're studying for the quiz, right? Because we have these, one of the things that should be on the quiz and the test is operations on functions. One of the big things students get confused about is how you actually do composition of functions. So, the big idea, the kind of sneaky thing in this was that I had a horizontal line. And so, like, you can read the values of the G from that. All right. Problem 8. Again, a hole in the graph. Because we've got this pesky x minus 1 up and stairs and downstairs. So what's left when you cancel those out is the reduced function. When you plug 1 into that, you find out that the hole at 1 is actually at -1/8. So when we have division that gives us vertical asymptotes at like -3 and 3, the numerator is 0 when we put x equals to 2/3. Yeah? If you set 3x minus 2 equal to 0, that gives you where the x-intercept is. And so that gives you a picture, kind of sort of like this. What was this? Which was what number? What? Did this get on the board? What am I going to see? Hey, yeah, kind of, sort of. Maybe add a vertical asymptote. And then there's a hole here somewhere, right? But not far off. I'm on your side. I want to see correct things. Like, I'm not rooting for you guys to lose. I want you to win at the quiz, all right? Problem 9, I don't think anybody in here did. Problem 10 is like what we did before the exercises. Problem 11 is important. Everyone should understand problem. I don't think I gave anybody problem 11, did I? I don't think I did, but everyone should study problem 11. It's just a vertex parabola problem, an x-intercept parabola problem. Again, it's got this, see this, in problem 3 we figured out what A was. That's happening again here. I know that there's some constant here. I've got x-intercepts of -3 and 8. How do I figure out what A is? Well, I got a y-intercept of 10, so I got to plug it in and solve for A. When I solve for A, I get 10 over -24, which is -5/12, so I put it back up there. That's the answer. So make sure you take a minute or two to look at problem 11. And then finally problem 12 was the last one you guys tried, I believe, over there. And signs of life, I think. So your graph might be like, I don't know, I'd have to like plug some numbers in to see whether or not. But listen, when I draw these graphs, I'm more interested in making sure that my reader can like see where my x-intercepts were. And like, I should really label these, right? This should be labeled -3, -2, -1, 3. I just was in a hurry when I wrote this solution, yeah? So it's not optimal. Like I've always labeled those in class, right? Every example we had, I like labeled the x-intercepts. I want you to do the same. And so anyway, there's this one. The horizontal asymptote of 1 is because it's quartic. It's the 4th order. It's the 4th order. And so the leading coefficient of the top and the bottom is 1. So my horizontal asymptote's 1 again. And then this is just, the critical numbers and plugging in points. And there's the graph. Where are the vertical asymptotes coming from again? Why is there a vertical asymptote at -4 and 4 here? It's because these guys, right? So anyway, that's it for today. I'll see you guys Thursday. And what we're going to do is we'll have the quiz at the start of class, and then I'm probably going to show you the solution to the quiz at the end of class, okay? Unless you guys would like